calculate the time at which the two balls will move at the same speed. That is 3.3. Let's take a look. A liner stands on a balcony 5 meters above the street and throws ball A vertically upwards at a velocity of 5 meters per second. At the same time, another learner throws ball B vertically upwards from the street at an initial velocity of 80 meters per second. Ignore all effects of a friction. Alright, and we're given a sketch, quite neat. It shows us exactly what is going on. I don't think there's a need for us to create another sketch. So the first question, 3.1, define projectile motion. I'll let you do that. Let's take a look at 3.2. Calculate the maximum height above the ground reached by ball A. Seems like an easy question because it is an easy question, but most people make a silly mistake. Let's take a look. So 3.2, sticking to the basics, we want the maximum height for ball A. So what is the initial velocity? It's given to us 5 meters per second, right? We know the acceleration, obviously 9.8 meters per second squared. Do we know the time? We don't know the time, but we're looking for the maximum height. So we actually know VF, because VF at the maximum height is equals to 0 all the time. Right, so we have VI, we have acceleration, we have VF, maximum height, so delta Y. Looking at these variables, it should be obvious that we then need to say that VF squared is equals to VI squared plus 2A delta Y. So VF squared, that is going to be 0 squared, which is equals to VI squared, taken up as positive, obviously. Maybe let me not say obviously. VI squared, that is going to be 5 squared, plus 2, the acceleration is minus 9.8, delta Y is what we're interested in. So delta Y will be equals to. So because this is physics and not mathematics, I'm just going to substitute and find delta Y in just one step without wasting any time. So 5 squared divided by 19.6, that is 1.2755. So that is my delta Y. But what are we looking for? We're looking for the maximum height above the ground. This is the mistake I was talking about. Most people will just leave the answer here, but it's incomplete. You need to take it a step forward. So the maximum height is going to be equals to the height at which it was projected, 5 meters above the ground, right? As you can clearly see on the sketch. 5 plus delta Y, 1.2755. So obviously that is 6.28 meters. We're rounding off to 2 decimal places. Right, that is 3.2, but I know you're really interested in 3.2, in 3.3 I mean. 3.3 is what we are really interested in. Quite a good question. Calculate the time at which the two balls will move at the same speed. I think the key thing in this question, which a lot of people might miss, is at the same speed. Not at the same velocity, but at the same speed. Because saying at the same speed introduces something to the equation that is not necessarily true. Well, it is true when it's the same velocity, but let me just show you what I'm talking about. So, ball A, we have VF is equals to VI plus A delta T, right? And then VF is equals to VI, obviously, which is 5 meters, minus 9.8 delta T. This is the velocity at which, well, this is the speed at which the speed of ball A and ball B are going to be close to each other. Right, so this is with regards to A. Let's move to B. When we move to B, we get VF is equals to 8 minus 9.8 delta T. So this is for B. So how the hell can these two things be equal to each other? How the hell? Because if we just equate this equation, minus 9.8 delta T and minus 9.8 delta T are just going to cancel out if we equate these two things. But we're talking about the speed, right? So they might cancel out because one object is moving upwards and another object is moving downwards as they pass each other. So that's why minus 9.8 and minus 9.8 might cancel out. But what do we do then to compensate for that? Okay, if the speed of A is equals to the speed of B at some point. Then the velocity at those 2 points, if we square them, they should be equal to each other. If we don't square them, they're not going to be equal to each other. If the one ball is moving up and another ball is moving down. This is the grade 12 final examination. Like the grade 12 final examination. The examination that decides the future of most people. So let's take a look at what's happening. So Friday, the 31st of October, is Mathematics Paper 1. And on the following Monday, the 3rd of November, is Mathematics Paper 2. Right. That very same week that you write Mathematics Paper 2, you write Physical Sciences Paper 1 on Friday. And on the upcoming Monday, you write Physical Sciences Paper 2. But let's be honest with each other. There's still a few topics that you're struggling with in math and science. If you go to my YouTube bio, you'll find 3 links: book one-on-one session, course, and email. So where you want to click on is book one-on-one session. You've taken a step in the right direction, and now it's time for you to book a session with me. One-on-one session is focused support tailored to your needs, and the group session is an interactive session for you and your friends. So you can invite your friend, a few friends, and then we can have the session together. So let's say you want to book a one-on-one session. So you're going to click on that. You'll decide on how long you want the session to be. Do you want the session to be an hour, 1 hour, 30 minutes, or 2 hours? Let's say you want the session to be 2 hours, right? So now it's time for you to select a date. Let's say you want to have the session on September the 4th. So you're going to click on that. And after you do that, you're going to see the available times. So if 5 p.m. work for you, you're going to click 5 p.m. And if 6 p.m. works for you, you're going to click 6 p.m. So let's say you want to book a session for 6 p.m. So you're going to click that. After you do that, there's a few information that I need. First things first, I need your name. So let's say, for instance, your name is John, right? The second thing I need is your email. So john@gmail.com, right? And then I need your number as well. Another important detail that I need is the topic that you need help with. So let's say, for instance, you need help with acid and bases, and to be specific, pH calculations. If you have any further question, you can WhatsApp me or give me a call on the number provided, or leave a question and I will give you a call, right? And after you do that, you just need to make a payment to the account provided based on the amount of hours that you want. Final exam is around the corner. You need to act right now. Can't wait to hear from you. But if we square them, therefore they're going to be close to each other. So this gives us 5 minus 9.8. Let me just say t, right? T squared is equals to 8 minus 9.8 t squared. Right, t squared. Yeah, because the speed is a scalar, right? It's not a vector, so we negate direction completely. Yeah, but then if we just equate VF and VF, we are not negating direction. So that's why it cancels out. It seems like the question is wrong, but the question is totally fine. Okay, so let's get on. 5 multiplied by 5, that is 25. And then 5 multiplied by 9.8 multiplied by 2, that is 98. So minus 98t. And then 9.8 squared, that is 96.04 t squared, and then that is equals to 8 squared, 64. 9.8 multiplied by 8, that is 78.4. We multiply that by 2, we get 156.8. so minus 156.8, and then plus 96.64 t squared. So 94.64 t squared and 96 rather. So 96.64 t squared and 96.64 t squared, that will cancel out. So we're going to be left with 25 minus 98t being equals to 64 minus 156.8t, right? So 64 to the other side, 25 minus 64, that is minus 39. And then what about minus 156.8 plus 98? That is minus 58.8t. So 39 divided by 58.8, that is 0.66. If we run it off to 2 decimal places, right? 0.66 seconds is equals to t. So that is the answer. That is the time at which the two balls will move at the same speed. So what you want to do, you want to substitute 0.66 in this equation and this equation and see if you don't get the same answer. You are supposed to get the same answer. Let me know which answer you get in the comment section. Right. So that is 3.4. 3.5, sketch a velocity time graph for the motion of the two balls until they reach the same speed. Clearly indicate the following values on your graph. Initial velocities of both balls, time at which ball A reaches maximum height, and time at which balls time at which the balls reach the same speed. Alright, we were only interested in 3.3 here. I'm just going to let 3.5 pass. Let me know which question you want me to do next in the comment section. Here we go.